5G and edge computing bring with them tremendous promise, but many of the technologies are difficult to understand. With this in mind, Aarna Networks brings you a series of tech talks in which we will interview our subject matter experts who will explain these technologies in easy to understand terms.
So, my name is Paulomi, and I will be interviewing my colleague Yogendra in this Tech Talk. Hi, Yogendra. How are you?
Hi, Paulumi.
What is network slicing in 5G?
Yeah, so that's a very interesting question which you have asked. In 5G, right, the network slicing is defined in terms of the various domains what we have today, and each domain have its own characteristics defined, right? So today, if you have to give a differentiated treatment for any customer, right, for their requirements, for their customers, respective customers, right, you need a way to carve out that, right, and that you have to carve out from your underneath infrastructure, which is your radio network, transport network, and the core network, all the three elements, right? So in essentially, if you look at it, what we are saying is the mobile network operators are now able to give a differentiated treatment for the respective requirements for their customers, and that they're doing it by the means of a tenant. Okay, so when we say tenant here, we're saying that each tenant can be governed by its own requirement, service level agreements, and the subscription. So this is what, in a nutshell, is 5G network slicing is.
How is network slicing solving the problem?
Sure. So in order to take the advantage of the network slicing, right? So there are a couple of use cases which are attached or will get benefited, and those are in the respective verticals of the businesses. There are 5 use cases primarily which I can think of immediately, which comes to my mind. First one is your enhanced mobile broadband, right? This one facilitates your enterprises and end user experience itself, right? So if you have a branch office today, and if you want to extend to your branch office with a better bandwidth, right? So what you have to do is you have to build up today underneath infrastructure, scale them up, and then provide it. So it takes a lot of time, right? So with the network slicing, it is very quick, because your network functions has now turned around to be a cloud native network functions, right? So you don't have to worry much through your underneath network infrastructure. Just you have to use your management orchestration to do that activity, and you can immediately get a better network slicing or better characteristics for your slice itself, right, for your respective use case. Similarly, you have another use case is called ultra reliable low latency use case, which is primarily meant for your sectors like financial, right, trading, for example, look at it, right, or health sector, where you are trying to do a remote surgery and you would not like to compromise on a latency, right, where latencies are very strictly defined, right, and because you would like to take the advantage of the latency defined, you perform a certain actions there for your application, right? So though that is the ultra reliable low latency use cases. Similarly, you have massive IoT use case, right? Now, given that evolution of the technology has happened, and many of the devices are now getting connected to each other now. In fact, billions of devices are there today, and so all of them are getting connected. So the density of user equipment is quite high within a given kilometer area, right? So that is another use case. Now all of them wanted to connect and provide certain services. Like example would be in a smart city, you have at the street side you have a video vigilance going on, right? You would like to capture that, right? So within a city, you can think of how many such video cameras can be there, right? So that is another use case of it. And similarly, you can think of a vehicle to anything communication, right? So now with autonomous vehicles and unmanned vehicles, right? You would let your devices, right, or in this case is a car itself, right, or vehicle itself should be able to judge what it has to do next step, right, and that judgment has to be facilitated by the characteristics of the network, right, and that's where you can say I need a dedicated bandwidth and dedicated latency attached to my application to work appropriately, right? So that's another use case. And then you have a high performance machine type communication, right, like a robot or assembly line, where you are trying to, like, if I take an example of a refrigerator which is getting manufactured or production is happening, right, you would like to do it in with a very high performance, and within a small window you would like to do a quality check and then proceed to the next step, right? So there are various use cases to it, and over and above these 5 use cases which I mentioned, there can be custom use cases also, which based on the business type, it can evolve.
Okay, that was very nice explanation. So can you explain a little bit more on how network slicing is implemented in 5G?
Yeah, that's an interesting one. I think for that, I would prefer to show some slide, 1 or 2 slides, and then I can talk to it. Like I was mentioning previously, right? When we say end-to-end network slicing, there are 3 domains which participate. One is, on the left-hand side of this slide, you'll see is the RAN slice, and then in the middle you see the transport slice, and then the core slice is on the right-hand side, right? So these are the 3 domains together facilitate network slicing end-to-end. Okay, and various use cases which I mentioned, like EMBB or URLCC or massive IoT or HMTC or V2X, all of them are riding on top of these 3 domains. If I have to quickly zoom in into one of the domains and see how does it helps us, maybe let me take a look of this slide to you. Right, so what we have done is in this slide is we are showing you 2 slices. One is the blue, other one is the green. And those slices are getting exercised from the user equipment, which is your 5G phone in this drawing. And then the phone is actually trying to connect with your radio, which is through your G Node B. Right. So the radio component is not shared. If you look in this drawing, right, this is non-shared ones, right? And then the radio is communicating to some of common network functions in this, which is your AMF and NRF and NSSF. And these are the 3 network functions which is getting common. However, your data traffic, which is going to go to your, the network functions like UPF, right, which is non-shared here, right? And the respective authentication of the user equipment, which is your 5G device itself, is also is separated, which is AUSF in the slice 1 and AUSF separate instances running in the slice 2, right? Which means we have taken care of a situation of privacy of the user equipment with an instance of separate AUSF, right? And then you have a dedicated UPF running, which is non-shared, which is catering to the characteristics of the network slice defined by the blues network slice, right? And same goes with your slice 2, which is a green one, right? In essentially, if you look at it, the core network is can have many network functions, and this network function can be exclusive or it can be partially shared, right? Depending upon the use case which you're trying to exercise. So I hope this will give you an understanding of how the network slicing works in totality.
Okay, Yogendra. So that was very insightful. Thank you so much for your inputs.
Thank you. Thank you so much.